So after looking at what vectors are, we're going to talk about what are the operations we can do on vectors. So if you want, you can look in your textbook, pages 34 to 36, to have all the notes, but I'll just show you a few examples so you can see what we're talking about. So first, adding and subtracting vectors. You can add or subtract vectors, and the result will be another vector. So for example, if you have vector A, and then you're adding vector B, you're gonna get the resultant vector A plus B from the tail of the first one to the head of the second one. Yeah, that's it. Now, if you subtract a vector, you can think about its equivalent to adding the opposite vector. Okay, so for example, if this is my vector A and this is my vector, oops, sorry, this is my vector B, and I want to do A minus B, it's equivalent to do A plus minus B. So what is minus B? Minus B is exactly the same, but in opposite direction. So I'm going to do A. I'm going to take my vector A here, plus minus B. It's going to look like this. Okay, so what is my final solution? I start from the tail of the first one, and I'm going to the head of my second one. So let's look at some examples. If you have to do A plus B, so you start with your vector A, and at the end of A, you put your vector B. So your answer will be from the beginning here, going to the end, that is A plus B. Now, if you have to represent V minus W, you have to remember that it's the same as adding the opposite of W. So first, you have to find the opposite of W. So the opposite of W is the same length, but opposite direction. So you're going to start with V, and then you're going to add, oops, sorry, V here, add the opposite of W. So your answer is going to be from the beginning to the end. So this is V minus W. With that, you can you're going to be able to apply Chass's relation. What does it mean? So they realize that whatever A, B, C you would have, let's say you have 3 points, so you have A, B, and C. Okay, if you're doing AB plus BC, then your answer is AC. It doesn't matter where your letters are. So what you realize is the last letter of your first vector is the same as the first of your second one. So AB will connect from B to C, so your answer will straight be from A to C. You will use that in different shapes or figures. So you really need to practice that to see it on, for example, parallelograms or rhombus. Okay, you have to remember parallelograms. They have 2 sets of equal and parallel lines. So that's a parallelogram. And the rhombus definition is 4 equal sides. So that's for the rhombus and the parallelogram. If you have your vector given in algebraic expression, also in coordinates. So for example, here you have vector A, that is 4. So if I'm here, I'm going 4, 1, 2, 3, 4, -1. So that's my vector A. And B is, if I'm starting here, -3, and then 6. Oops. Just a second. Okay, so I'm here, -3, 1, 2, 3, 1, 2, 3, 4, 5, 6. This is my vector B. So I could represent them and add them up, but it's a bit easier than that. What you can do is you can just add your x coordinate. So you're going to find your x component. To find your x component, you're going to do 4 plus minus 3. So it's going to give you 1. And to find your y component, you're going to use minus 1 plus 6, which is going to give you 5. So if you have to do a plus b, your result would be 1, 5. If you want to represent it, you would go 1, then 1, 2, 3, 4, 5. It would give you this. If you want to check if it works with the vectors, you can take your a plus your b, and you see we would get our c there. Okay? Oops. Sorry. Okay, and then we can do addition, subtraction, or we can multiply a vector by a scalar. If you remember, a scalar is just a number, right? There's no direction. So for example, if you have a scalar k, so it's a number, and you see there's no vector sign on the top, you multiply that by a vector v. Okay, so the product of k times v can be found by multiplying each component by the given scalar. So for example, if you're given v, which is 3, negative 1, and you multiply it by 5, then each component will be multiplied by 5. So your final vector would be 15 minus 5. To know what it looks like, okay, you can look down here. This is 3. I'm going to show you 3, 1, 2, 3 minus 1. This is your vector. If you look, I put it here. You multiply it 5 times. So 1, 2, 3, 4, 5. Just going to bring it down a little bit. So your final vector is that long vector. This is 5v. Because see, we have v repeated 5 times. Okay, and so the coordinate would be 15. So you'd have to count to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then minus 5, 1, 2, 3, 4, 5, something like that. Okay, and then you would get, actually your 5 should end here. Okay, something like that. If you multiply by a negative, it's going to change the direction. So for example, this is your v, and you can see it's there 3 times, but on the other direction. So this is negative 3v, because it's going the other way around. And also a few things you need to remember. 1u is the same as u, because you don't see the one there, but it's there. It's the same as in algebra. When you have negative, then it's the same. We don't put the negative one here, but it's there. And if you have 0 u, we can also bring it back to the 0 vector, if you remember. And when you have a component, a scalar k, multiplied by your vector 0, it's going to bring back to 0. You can also decide to decompose your vector in terms of horizontal vector and vertical vector. So for example, if you think of a vector u, it would be the sum of the horizontal part plus the vertical part. They also show it to you as the projection of u on the x-axis. So this is your u over here. Your projection on the horizontal axis is right here, and the projection on the vertical axis is on the left. What does it mean when you have your vector u of, let's say, magnitude 5? How can you find the horizontal component? So you're going to use sine, cosine, or tangent. Because it's adjacent, you're going to use cosine. Cosine of 53.13, sorry, is equal to adjacent, which is your x value, over hypotenuse. So your x value is 5 cosine of 53.13. That's your horizontal component. So for vertical, you would do exactly the same thing, except for the vertical. If you look on the picture, it's the opposite side to the angle. So we're going to use sine of 53.13. That equals opposite over hypotenuse. So this is your vertical component. It's always better to keep all your decimal. If you want, you can find the approximate value, but please do not use that one for further calculation because your final calculation will not be correct. And last, just few properties of operation on vectors. So commutativity is if you have u plus v is the same as doing v plus u, you can switch them around. Or you can add the first two one and then the third one, or you can start with the first one and then add second and third. Also with the multiplication of the scalar here, again you can do associativity. That means you can multiply your two scalars together and then after your vector, or you can start by one and then after the second one. If you have an addition with your scalar, you can distribute. And same if you have two scalar with your vector, you can distribute. So now you can start the practice in class and bring your questions if you're not sure.